Number 1, we've determined that this is probability is area shaded. Area shaded compared to area total. This one's pretty easy because the area shaded, it's a 4 by 4 square. 4 times 4. And the total area is the area of this whole big square, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to assume it's a square. I'm going to make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good thing I checked. Not a square. It's a 9 by 10 rectangle. So I have 16 over 90. That's 8 over 45. And there's no, yeah, that's it. 8/45. Pause while I check my, yep, good. 8/45 for that one. That would be nice if I would show that. All right. Probability of shaded equals the shaded area compared to the total area. Well, that's weird because there's so much more shaded than there is unshaded. I have an idea, but I don't see why not. Let's do the probability not shaded. That's the probability of the white area compared to the, no it's not. It is the white area compared to the total area. The white area is easy to find. It's a 4 by 4 square, so that has an area of 16 compared to the total area, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's a rectangle. It's 15 by 15 by 6. So 90. 16 over 90 is 8 over 45. So if the probability not shaded is 8/45, the probability of shaded must be the complement, or 37/45. That's correct, 37/45. You could have found the shaded area and compare it to the 45, you'll get that. It's just like taking the 90 and subtracting 16 from the 90, which is what, 74 over 90, which when you factor out the 2 halves gives you 37/45, if you did it that way. Number 3, much easier than it looks. Get a better color. The area shaded over the area total equals pi times the shaded radius squared over pi times the total radius squared. Get a better color here. The radius for the shaded circle is 2. So pi times 2 squared over, let me just show a radius, and that would be a bad idea. You get a different color. If I go from the center to the edge of the whole circle, that's 4. So pi times a radius of 4 squared. 2 squared is 4, so I've got 4 pi. 4 squared is 16. 4 pi over 16 pi. The pi's cancel. This is why you don't substitute an estimate for pi. It says the circular areas, calculate them exactly. Pi divided by pi is 1. And 4 and 16 have a common factor of 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So this probability is 1/4. Number 4, very similar to the number 3, but, all right, let me, I'm gonna refer to 3 circles here. I'm going to refer to the area of 3 circles here. The total being the whole big circle, including the white area. The shaded, which would be the total area minus the white circle. and the white circle. The white circle is pi r squared, where r is the radius of the white circle. It's 3. So the area of the white circle is pi multiplied by 3 squared, so 9 pi. That's the area of the white circle. The total area is pi r squared, r total, the total radius, the radius of the whole big circle. So 1, 2, 3, 4, 5, radius of 6. So the area of the total circle, which would include this gray shaded area and this white area, is pi multiplied by 6 squared. So the total area is 36 pi. But we want, for the probability of shaded, we want the shaded area compared to the total area. We just figured out total area is 36 pi, but we don't yet have the shaded area. But we can use this relationship, understanding that the total area minus the white area would leave us this gray shaded region. So the area of shaded equals total area, we just figured out is 36 pi, minus the white area, which we calculated was 9 pi. And in these two terms, I'm counting pi in both terms. It's like saying, what's $36 minus $9? $27. What's 36 pi minus 9 pi? 27 pi. You're counting a thing. It's like 36, let's do a fraction problem. 36 75ths minus 9 75ths is 27 75ths. This is why we need a common denominator, so we have like terms. If you're counting the same thing, then you can combine them. So 27 pi becomes our shaded area and our numerator here. Fortunately, the pi's cancel. And also, fortunately, there's a very large common factor. The greatest common factor of 27 and 36 is, of course, 9. 27 divided by 9 is 3. 36 divided by 9 is 4. So as complicated as that problem seemed, the probability is pretty straightforward. It's 3/4. 3/4. Problem 5. Let me do this right. The probability of landing in the shaded area is equal to the shaded area compared to the total area. The shaded area is quite simple because it's a parallelogram, more specifically a rectangle with a base of 1, 2, 3, 4, 5, 6, 7, 8, 9, base of 9 and a height of 2. So 9 by 2 rectangle, area of 18. The total area is the area of a triangle. So it's 1/2 base times height. The base is 1, 2, 3, 4. You know, it would have been smarter. This is 9. This is 1, 2, 3, 4, 5 more than that. So 14 plus 1, 2, 3, 4 over here, 18. That base is 18 if I did it right. The height, the perpendicular distance from the vertex to the base, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I did it right, it's 1/2 multiplied by 18 multiplied by 11 for the total area, which includes the shaded rectangle. Half of 18 is 9, and 9/11 is 99. And so substituting into this probability, the shaded area is 18, the total area is 99. Both of those have a common factor of 9. 18 divided by 9 is 2. 99 divided by 9 is 11. So 2/11ths would be that probability. I can't find it. There it is. Yes, that's correct. 6. Probability of landing in the shaded region equals the shaded area compared to the total area. Total's easy, the easy one here. The total area, it's a big rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by 3, 4, 5, 6, 7, 8. 16 by 8 rectangle, which is 128 units squared. The shaded, I've got a composite figure, but a pretty easy one, made up of 2 rectangles. One of them is 2 by 3, 4, 5, 6, 7, 8, 2 by 10, aka 20. And this little rectangle is 2 by 3, also known as 6. So the shaded area is 20 plus 6, or 26. When I substitute into this formula, which I've sadly not left room, 26 over 128. I know there's a common factor of 2. I don't know if there's a common factor greater than that, but I don't have to do it in one step. 26 divided by 2 is 13. 128 divided by 2 is 64. 13 is prime and 64 is not a multiple of 13, so I know that I'm done. 13 64ths. Checking my work, yes. Number 7 we did as the do now. Number 9 is quite tricky. Although we've looked at something like this before. The probability shaded is equal to the shaded area compared to the total area. I'm going to do the easy one first. The total area, which would include all this white region and all this gray region inside this bold outer border, would be the area of this large rectangle, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Base of 15 and a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15 by 11. Nice round number, 165. Total area is 165. Now you can't find the shaded area. I defy you to find the shaded area. You don't know how long this base is. You could do some, you could do a little Pythagorean theorem trickery and find the hypotenuse of this triangle. But even if you did that, how are you going to find this perpendicular distance to that base? Good luck. There must be a way, but I don't know it off the top of my head. But you don't have to find that shaded area directly. Isn't that shaded area? If it's not easy to find if it's not easy to calculate the shaded area, calculate what the area that's not shaded. Because the shaded area is equal to the total area minus the white area. In other words, if I start with this big rectangle, which we've already determined is 165, and I take away these 3 white triangles, won't I be left with the shaded area? And aren't these 3 conveniently right angle white triangles very simple to calculate? So area of triangle 1 is 1/2 times the base of triangle 1 times the height of triangle 1. Area of triangle 2 is 1/2 times the base of triangle 2 times the height of triangle 2. Area of triangle 3 is 1/2 base 3, height 3. Triangle 1's base is 4. So area of triangle 1 is half of 4 multiplied by a height of, we already know the height, it's the height of the rectangle, 11. Half of 4 is 2, and 2 11ths is 22. So area of triangle 1 is 22. Area of triangle 2 is half of the base, which if this is 4, this must be 11, using this concept. And the height is 3, so half of 11 times 3. So half of 33 is 16.5. Area of triangle 2 is 16.5. Area of triangle 3 is 1/2 of the base is the same as the base of the big rectangle, 15. 1/2 of 15 multiplied by the height. Well, if this is 3 and this is 11, this must be 8. I'm going to associate to my advantage and take half of 8 first, which is 4. 4 15s is 60. So the area of triangle 3 is 60. The white area, that's nice penmanship, is the sum of the 3 white triangles. So 22 and 16.5 and 60 is a 98.5. Sounds like a radio station. Those don't really exist anymore, I don't think. 98.5. Now, oh boy. Oh boy. Is this one hard? I hope you, well, let me not say that. Let me think about what I'm saying so I don't have to edit this video like crazy like I always do. All right. If the white area is 98.5, we're subtracting 98.5 from the total area, which we've already determined is 165. Now look, I don't do this. I don't do this either. I'm not going to do this. I could do that, but I've got an easier way. Just subtract 100 from 165, and you get 65. That's easy. But I subtracted 1.5 more than I should have. So add 1.5 back in. Oh, that's called compensation. 66.5. That's the easy way. So the shaded area is 66.5, but this is not simplest form. This 66.5 1/65, it's kind of like the opposite. That's not the best word, but it's kind of like, usually we have to simplify. Here we need, by dividing out a common factor. Here we need to multiply by some version of 1. We need to multiply by 2 halves so that my numerator becomes a whole number. You don't want a fractional number in your numerator or denominator. That's a complex fraction. But 66.5 doubled is 133, and 165 doubled is 330. And 133, 330 is the answer. That's a hard problem. Number 10. Area shaded over area total. That'd be the probability of shaded. This time the shaded area is the easy one. The shaded area is 1/2 base times height. So 1/2 of a base of 4, a height of 4. 4 is a 16, half of 16 is 8. So the shaded area is 8. Total area is tough. That's tough. Something like this came up once this year, but probably only once. It probably had to do with intersecting circles though. Okay, it is not easy to find this total area. Here's what you have to do. You have to find the, I keep grabbing the wrong tool, sorry. You have to find the area of this triangle. First, let's do that first. I'll call it area yellow. It's 1/2 base times height because it's a triangle. So 1/2, this base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's nice. 1/2 of 10 times a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's nice too. Half of 100 is 50. So the area of the yellow triangle is 50. Alright, let me get a different highlighter color. What would work well with yellow? Probably blue. Find the area of the blue triangle. area of blue is 1/2 base times height. I realize they might be congruent, but I don't want to assume it until I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is a base of 10. Half of 10 times. Oh, I know. I can tell the height's the same. They are congruent. So area blue is also 50. Now, here's where we have to be careful. What's a good color for outlining this thing? Probably this color. Okay, remember that the region that we consider the total area is this region. Like everything that's inside that whatever color you call that. I'm not good with colors. Burgundy? I have no idea. Whatever's inside that. Which is area yellow plus area blue almost. Except we've got this overlapping section, right? That overlapping section needs, look, this section needs to be included, but if we add the two triangles, we've included it twice. I know how to think of this. Think if you had like the yellow triangle literally like a piece of construction paper, and the blue triangle another triangular piece of construction paper, and you overlap them the way you see on this picture. Wouldn't that little triangular section be counted, double counted, if you just added the two areas? You need to subtract that triangle once. It's supposed to be there once, but it's just not supposed to be there twice. If we just add the area of the two triangles, we've double counted it. So we have to, the area total equals area yellow plus area blue minus the area shaded, which we know calculated before was 8. So we've got 50 and 50, but you have to subtract the 8. So 100 minus 8 is 92. So the denominator is 92, and there's a common factor of at least 2 here. Although is 92 a multiple of 4? It is, because 80 plus 12. So I'm going to use the greatest common factor, which is 4. 8 divided by 4 is 2. 92 divided by 4 is 23. So 2/23. That was a hard problem. The last two are hard problems. Well, look, I can tell you for sure, this would have been way too much for one lesson. So I always want to try to give you, well, look, if I think back to what I said before we started, like on the video right after the homework grading on this Nearpod, I gave you options. So I think it was clear there that you shouldn't work more than 45 minutes. So, but I know some of you probably can't help yourself. I hope it didn't. Well, there's a video here helping you, so I hope you use the video if you got stuck. I'll just say that. I'll thank you for your hard work, and have a nice 3-day weekend. All right, class dismissed.